back, Math 8. Today we are continuing last lesson. I originally planned to finish this section, which is identifying patterns and identifying the value of slope last time, but we spent a lot of time for detail and it ended up having two parts. So consider this as a part 2 of identifying patterns and writing in an expression and slope. We're going to focus on 2 examples like last time, and I have the feeling it's going to be taking equivalent time. It's page 17 of your math booklet. So without further ado, let's get this started. Photo World charges $3 for the first enlargement and $2 for each additional enlargement, which is I believe this is picture of elk, I think, and we have the example given. Our to-do list is make a table of value using the word problem that show the cost in relationship to the number of enlargement, and we need to explain if it's linear or y, and we need to find out what's expression for the cost in relation to the number of enlargement. Lastly, what is the cost of 15 enlargement? So this is a good recap question from last time too. And for people who struggled the first lesson, this is a good reinforcement. I'm going to highlight some of the important part of this word scenario. First thing first, $3 for the first enlargement. This is a basic fee, flat fee. It's the very first cost that you have to pay. But after that, $2 for each additional enlargement. So $2 per every single thing. So for each, that already kind of telling me that this is my independent variable, which is my input scenario. Technically, it's not $2 per, but about this each section. Before we getting into anything, it is a good idea to construct a table. Like the word suggests, the question says, make a table of values showing the cost in relation to the number of enlargement. So we can choose to use some variable like cost can be used as C, number we can use N, something like that. Some people who like to still use X and Y, then just know that cost depends on the number of enlargements. So this is like Y and this is like X. But I'm gonna use the scenario wise. Cost, I'm gonna use the variable C. Obviously the cost unit is $. Number of enlargement, I'm gonna use N. And that's how we're going to construct. So, according to the question, the first enlargement, I actually reversed an X and Y. So you know what? Sorry about that. Just know the fact that you need to change left and right. But you know what? This is a good example. What you're going to do if the Y-axis is our first one. Because that's possible. But regardless, the first enlargement costs $3. But afterward, when you have second and so on, we have $2 cost for each additional. So $3 plus 2, that's 5. When it comes to third one, 2 additional dollar from the previous one, so that will be 7. Let's do one more. If I have 4 enlargement, then 2 more dollar, so 9. So as you may see, I construct a table that shows the relationship between the cost and the number of enlargement. So the first part, A question, is done. Now using this, we gotta explain if this relationship is linear and y, and the way that we can find this, we can explain everything using the slope. Remember, slope, you need to compare the consecutive value for each of the column in that situation. For a number of enlargement, as you may notice, it is added by 1 for each situation, but when it comes to cost, as you may know, 3 to 5, 5 to 7, 7 to 9, we know that it's additional $2. So, now let's think about our graph situation. Before we getting into slope, it's a good idea to go through the graph, and I'm going to explain to you why. If I construct the graph, know the fact that number of enlargement is located at the x-axis. When it comes to y-axis, it's a cost, which is $sign over here. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The first one costs 3. Second one costs 5. Third one costs 7. Fourth one costs 9. Which is, over here. Yep. So if I connect them together, that's what we have. The way that we can find the slope is, first of all, horizontal part is N, vertical part is C. So, slope, let's think about it, rise over run. Vertically, how much we're increasing? Well, from each of the point, we have 3 to 5, 5 to 7, 7 to 9. We are increasing everything by 2. On the other hand, running from 1 to 2, 2 to 3, 3 to 4, we know that it's increasing by 1. So 2 over 1, it's just positive 2. If we have this slope, which also if you're using a table, you will notice that this is a linear pattern because adding by 1, adding by 1, adding by 1, these guys agree. Same thing. For the vertical, added by 2, added by 2, added by 2. So long story short, it is a linear relationship because slope exists. And the slope turned out to be positive 2. Third, what is the expression for the cost in relation to the number of enlargement? Well, this is where things are getting a little tricky. We need to find the relationship between how the number change into the cost. So we are comparing the horizontal row. And then what we can do is we need to find out if it's adding relationships, subtracting, multiplying, or dividing. As you may notice, numbers are increasing. 1 turning into 3, 2 turning into 5, 3 turning into 7. So it's either adding or multiplying. If I look at adding part, 1 plus 2 is the one that we require for making it into 3. But does that work for the second one? No, it's not. It's 2 times 2 and then I gotta do something else. So adding isn't the problem. That means we gotta think of multiplying. What kind of multiplication can we do? 1 times 3 work for this one, but 2 times 3, it doesn't work. 3 times 2, it doesn't work. 4 times 2, it doesn't work. But, you know what? Or sorry, times by 3 in this case. 3 times 3 is 9, 4 times 3 is 12. However, you can combine adding and subtracting together. Is there any way we can use adding and multiplication, not subtraction, adding and multiplication to find a relationship? This is where prediction and guess and check is happening. If I multiply 1 by 2, then it's become 2. Can you add 1 to make it into 3? Yes, you can. If I do 1 times 2 plus 1. Does that work for this guy? 2 times 2 is 4, but 4 plus 1 is 5. So time by 2 and added by 1 work. What about this one? Does 3 times 2 plus 1 work? 3 times 2 is 6. 6 plus 1 is 7. So it does work. Does that also work for the other? 4 times 2 is 8. 8 plus 1 is 9. So as you may notice, even though it's tricky, there is a pattern. Multiply by 2, then added by 1. So what is the expression? Well, cost is equal to n times 2, which is 2n. Remember, number always comes first, added by 1. So that is the relationship. Once you find the relationship, then second one is easy. It is asking 15 enlargement, n is equal to 15. Then we need to find out what's the cost. So it is a fancy way of saying we need to find a good enough relationship by substituting. So when we try to do substitution, then here's what happened. 2 times n plus 1, we don't have to rely on that 15. C of the 15 should be 2 times 15, then plus 1, which is 30 plus 1, which is $31. And that's how we answer this word problem, changing into a table and graph, find out the slope so that we know whether it's linear relationship or not. And then lastly, we substitute and find out or predict the answer. Let's do last example of today. And fortunately, we have graph given, but now some people get panicked when there's decimal, but still, let's give it a shot. The cost of renting the skating rink for a birthday party is $100.50. There is a fee of $2.50 for each person. So the last statement already kind of tell you for each or per one is basically $2.50. So you know that this is per each. That give you the idea that this is my X. So that what if it's 0 person, 1 person, 2 people, 3 people, 4 people? I can change that number, which means the cost will be my Y. Oh, never mind, the equation is given. See, cost is equal to 150 plus 2.50. And then instead of X, the person used P. So this is my equation. We don't know whether it's linear or not, but our job is, number 1, to substitute using this table, and then we need to identify how many costs will happen if it's 22 people. So at least it's more straightforward compared to the other example, even if the numbers can be tricky. Let's give it a shot for each. I am going to substitute for about 3 different values. The first cost is when there's 0 people. Second one is when there's 1 person. And the third substitution is when there's 2 people. And then I'm going to identify if there's any increasing pattern. So 150 seems like a common number that we have, added by, and then 2.50, 2.50, 2.50, multiply by, the first one is 0, second one is 1, and third one is when it's 2 people. Good idea to take out your calculator. First one is easy because anything that multiply by 0 is 0, so it's $150 for the first one. The second one is 150 plus 2.50. You can give it a shot using your mental math if you can. That's $152.50. Then second one is, again, feel free to use your calculator. If it's 2.5, then it's $5, so $155. You don't have to rely on my, my mental math calculation. But you can use your calculator if you want. So 152.5, 155. If you look at the relationship, can you see that each of the row, if I look at P part first, every time you increase everything by 1, right? But when it comes to next sequence, can you see that 150 to 152.50, you're increasing $2.50. Does that happen again? Yes, we do. Then, can we guess what's gonna happen next? Is, well, similar as what I put. I gotta add by the same amount, $2.50. So 157.50. And when it comes to the next one, it will be 160 bucks. So long story short, we can predict the next values. But once that happens, my x-axis, which is the number of people, so I'm going to change into P. Y part, that's number of cost. So we can put C with the dollar sign. And we can start putting some number. But the way that I'm going to do is, can you see I put little squiggly equal sign over here? In science and math, that means we're omitting from 0 all the way to, I'm going to start with 150. Because know the fact that you don't have to draw 0 to 150 because there will be no value. At 0%, this is where things are starting, 150. The next one, I'm going to go 151, 152, 153, 154, 155. Kind of tedious now, so I'm not going to repeat it. You got the idea. And why don't we do, instead of its grid, like 1, 2, 3, 4, what about like every 2 grid? So that we can draw the graph better. For the first one, we have 152.5, so that's right halfway between 152 and 153. The second one, 155. Third one, 157.5. Fourth, 160. There you go. And you are connecting an entire line using a ruler, which I don't have. So, this is the graph, ladies and gentlemen. The question doesn't ask you about the slope, but if I go through each dot point, you are increasing horizontally by 1. And when it comes to down to up, each of them you are increasing 2.5, 2.5, 2.5, 2.5. And can you see that staircase that go up? So slope, if I look at rise over run, then now you can say that my rising was positive 2.50. And it's okay, you can have decimal number too. Run was every 1, because, you know, 1, 2, 3, 4. So my slope is 2.50. That means it is a linear relationship. You have a pattern, and that patterns are consistent. Last example is, how much will it cost to invite 22 people? Well, so people is 22. And obviously it's not useful if I add the number of rows so that it go all the way to 22. That's too much of effort. One way you can do is, if there's a 22 people, we can substitute $150 was a basic fee, plus all I need to do is 2.50 multiplied by how many people that is indicated by the question. So this time unit calculator, I recommend 150. Take out your calculator. I'm going to use a computer one. 2.50 multiplied by 22. Give me 11.00. $11. So only thing that I need to do is 150 plus 11, which is 161 bucks. And that is how much it cost for 22 people. That is today's lesson. The homework part will be shown right after this. Cost.